Hi, I think everything is perfect. It's live. Well, the 13th video. So if you have directly switched over to watch my first two videos, then you can continue. After my introduction first, I mean my first, again a milestone, one of the important videos because set up as I had promised, as we had shared. So the project is progressing. It's almost like a studio for me. But this is not the end. This is, I'm still experimenting, but it's a new setup. Yeah, almost it's on the way. So we'll proceed. Don't look at the problem. I think everything is visible. So it's enough if you see the problems. Later we will have the improvements. So again, two problems. We are proceeding one step again ahead. We started with speed time distance point mass problems. Next we moved on to problems on brains. So this is third stage, not third level. Third level means the difficulty. This is third stage, boards and streams. In fundamentals, I have already explained how to take the variables and what exactly is boards and streams. And I just remember few things. Again, it's night time, so I might speak slow. You would need subwoofer or some earphones. But as and when time progresses, recording in the time peak loud enough. So that time I don't think you need any. So until then, please bear with me. I'm sorry for that because this is the only time I'm getting. And remember, recently I came across a very good book, Krish Verma. Many might have heard about it, but I hadn't got much time to go through that book. But recently, I got an opportunity. I just went through that book. Excellent book. Few days back, I had spoken about the Agarwal. Even that time, I had said that I am not advertising anything here. It's just a sharing of good things. So I felt that book really wonderful. We can make the best use of it. It has a good number of problems, not only quantity, but he has thought about many aspects. Even I came to know, I learned many things from that book. It's Sarvesh Verma, a very good book. Especially it is dedicated to the quantum cat. I mean, for the MBA admissions. But we can use it for developing our fundamentals, understanding the concepts. So it's a just general point I remember. So we can proceed. This problem being the first, we will it will help us to understand, make our concepts strong, understand the fundamentals. This is somewhat complicated, but both come with lessons, and here we will solve. Don't read the problems yet. We shall proceed then. I will just read once. A man rose at the rate edge in still water, and his rate current is 3.5 kmph. Thence rate along the current is. So I have already explained in fundamentals speed in still water, what is stream, what is upstream, what is downstream. You can go to that video and be thorough with the fundamentals. Then you can come back to this video. Because every now and then we can't invest time, our time gets wasted. So let's proceed. Man's rate along the current is asked, that is downstream. You need to recollect from the fundamentals. Along the stream, along the flow of water is downstream. If a man rows at the rate of 5 kmph in still water, that is with, you can, in place of man, you can sit and imagine. That is how even I saw that helps you to visualize better. See, You are rowing at 5 kmph. I mean, with your efforts, you can row at 5 kmph because it's in still water. Against the means upstream, against the current is 3.5. 5 is 1.5. 1.5 is getting wasted. 1.5 is eaten by the stream. That is your efforts, which in that 1.5 is being consumed here because it's 3.5. So this 1.5 should be the current. Current in the sense that current is water current. The stream moves. So we got the speed of stream as 1.5 kmph. 5 still water, 1.5 kmph is speed of stream. Then the man's rate along the current. I have already said along the current is 5 plus 1.5 is 6.5. 6.5 is exactly the right answer. So I took this as the first problem because it is a very simple and it helps to visualize what's happening in boats and streams better. So I took this as the problem. I will just revise. Still water speed was given as 5. Since we know the upstream, we subtracted and got the speed of. So we know the both the entities. We got that because that is us. You can later pause and make your note. One more important, that is what you see in classrooms, many of the books, everywhere. What they do, or in all the problems of boats and streams, time 7 minutes. See, 5 kmph in still water. This will always be equal to 3.5 is upstream plus this is upstream speed. Downstream speed we have to calculate along the current. That we don't know, we'll take it as x divided by 2. 5 into 2 is 10. 10 minus 3.5 is 6.5. So we got the value as 6.5. So what I mean to say is the speed in still water will always be equal to the average of upstream and downstream, or downstream and upstream. You can also use this formula. If you want to write in the formula is half d plus u, downstream plus upstream, half means average of that will be always speed in still water. But this, all the videos I don't follow. Because question comes, why we are doing this? At many places I have seen students tell me, write this, they substitute the values, they get the answer. But that's not my motivation here. Why here if you take so, be it any topic, any difficulty, the way I solved previous method, we can easily solutions. We need not remember anything. Like this, I can give you a big list of formulas, but I personally don't follow it. I even don't try to remember. It's better to develop the solution. That's one of the major intentions of this channel. Then later you can even make a note of this. We can proceed. So even this problem is again very important one. Time is 9 minutes. A man rose, and again these two problems are from Agarwal, quantitative aptitude. Initially, it's better to study from that book. It has a very clear-cut problems. A man rose to a place 48 kilometer distant and back. He finds that 4 kilometer with the stream time as 3 kilometer against the stream. Stream is. So again, I forgot one more important thing. Don't write anything. Concentrate. Put all your concentration on the board. Understand it. Your notes. I said in some of the always when you get a problem, try to find what you need to equate. I mean to say, and back in 14 hours, some time is given, right? In 14 hours. So this is the time. We can, I think here it's more clear. Okay, I will use this. It's more bright. Time is 14. This is equal to, we can have two times here. Adding those, we get the total time. A man rose to a place 48 kilometers distant and back in 14 hours. Rose is important. He is not traveling on road. He is rowing on the river. So, and back means it has both upstream and downstream. Speed is distance by time. Time is distance by speed. Distance is 48 kilometers. Don't worry, I will change the ink. It's getting lighter. 48 divided by x plus y. 48 divided by x minus y. Again, at many places, you starts with some formula, but the question why? So this is the pattern. Time is given total time. This total this time plus this time. X plus y is there, so it is downstream time plus upstream time. If you add both the times, you get total time. So with this, we can't calculate anything because in maths, the number of variables we have, the same number of equations we should have. So he gives some hint. He finds that he can row 4 kilometers with the stream in the same time. Again, time is equating here. Speed is distance by time, time is distance by speed. So distance by 4 kilometers with the stream. So it is x plus y. This is equal to 3 kilometers x minus y against the stream. So why I took this? Because in order to calculate here, he has given one more word problem from which we can frame our equation. With the stream in the same. So I equated the distance by speed, equating the time. 4 by x plus y is 3 by x minus y. If you 4x minus 4y is equal to 3x plus 3y, just cross multiply. I have already said that these steps I will be neglecting. I won't write, but it's the beginning. We can 4x minus 3x is x, 4y plus 3y is 7y. We got x equal to 7y. So this we can make use of here. I will just rub. Later you can make a note. Okay, I'll write here. 14 is equal to 48. X is 7y. 7y plus y is 8y plus 48. X is 7y. 7y minus y is 6y. 6 6 8. So 14 is equal to 6 plus 8 is 14 by y. So y is equal to 1. So this y is equal to y is whatever, and what is asked? The rate of stream is asked. So kmph 100% right answer. Time is exactly 15 minutes. So these are the first two basic problems on boards and streams. You can again replay the video unless and until you able to visualize what's happening here, because enjoyment comes only when you try to visualize the things, and that, or else it will be just a robotic process. So I'll just summarize, not in detail. Time was given, so we equated the time, we added times upstream and downstream and upstream to get total time. Later we proceeded to the second equations. From that we got x minus y, because even their time was same. I mean their time was same, so we equated the time and substituted to get the rate of the current. So be it any problem on the topic, this is how we will proceed. We can just go on developing the solutions just by reading the problem. You don't need any big list of formula. Just be thorough with these concepts and fundamentals. So see you in the next videos.